close till I get up.
Hello, we are from M9. So the main purpose of the project is to develop a material handling system to store 8 ping pong balls from the feeder into the container along the conveyor belt. Raspberry Pi is used as the microcontroller and the system is programmed by Python coding. The objective of our project is, first, to develop a material handling system by integrating various sensor and actuation. Second, to identify the pneumatic and electronic components and their function in operating the material handling system. Third, to learn Python coding and write a code to perform material handling process. Our system is designed to work as packaging machine for the bread. A humidity sensor is used to determine the humidity of the surrounding to prevent the bread become moldy. The bread is represented by the ping pong balls. First is Raspberry Pi 3B+. It acts as a controller for the material handling system, PLC. It is used as power supply of 24 volt, single and double acting cylinders. It is to hold and release the ping pong balls, 3 two-way solenoid and 5 two-way solenoid valve. It is to control pneumatic cylinder for retracting or expanding. Interface circuit to connect solenoids and relay to Raspberry Pi. Relays to on and off or change the direction of conveyor belts. Proximity sensors to detect the presence of aluminium plate on the box. Switch as start button and emergency stop button. Conveyor belt powered by motor to transport the board. DHT22 sensor to detect the humidity and temperature. Breadboard, resistor, and lastly wire.
Now we explain the design of this box. We choose this box as it suits well the dimension of conveyor belt. A hole is made to make sure the ball can enter it. Then we make a folded aluminum foil at a certain height near the hole to make sure the sensor is effective to detect it. Lastly, we choose the transparent box to make sure we can observe well the ping pong ball.
Hi, I'm Jer Jian. Today I want to explain the circuit of our project. The circuit consists of a PLC power supply, relay, solenoid, valve, proximity sensor, interface circuit, switches, and DHT22 sensor. The positive terminal of the relay and solenoid valve is connected to a 24 volt of the PLC. For the proximity sensor, the red wire is connected to a 24 volt of the PLC, and the black wire is connected to the interface circuit. 1.5K resistor is placed between the red wire and the black wire to step down the voltage. The blue wire of the proximity sensor is connected to the ground of the PLC. Next, for the switches, one of the wire is connected to the ground of the PLC and another one is connected to the Raspberry Pi. Lastly, for the DHT22 sensor, the connection is almost similar to a proximity sensor. The power pin is connected to a 3.3 volt of the Raspberry Pi. The data pin is connected to the GPIO and the ground pin is connected to the ground of the PLC. A 10K resistor is placed between the power pin and the data pin because the pull-out resistor will ensure a valid logic level when the pins are switching from input to output. And that's all for my part. Thank you.
Hi, my name is Kok Yung and I'm going to explain the Python coding. First, I import the useful libraries into my code and then I assign the components to the GPIO pin, and n is a global variables that representing the number of ping pong balls. And here I assign the relay and the valve as the output, the proximity sensor and the switches as the input. And here I define the read DHT22 functions, and the initial condition of our system is all the cylinders extended. And here is a while loop to print the humidity in every 2 seconds. And when the black button is pressed and the humidity is lower than 80%, the relay will start the conveyor and move to the right and move the box to the right. Then when the pigment balls is less than 8 and left proximity sensor sense the box, the relay will stop the box and the cylinders, the upper cylinders will retract, extend, and then followed by the bottom one retract and extend to release the ball to the box. And then the conveyor belt will continue to move to the right. And when the right proximity sensor senses the box, again the relay will stop the conveyor belt and the cylinders will do the same series of actions to drop the ball. And then the conveyor belt will move the conveyor, and then the relay will move the conveyor belt again, but this time will move the box to the left. During the process, if the rig switch or the humidity is higher than 80, the relay will stop the conveyor belt to terminate the process. When the number of pigment balls reaches 8, the relay will stop the conveyor belt and meaning the process is end. And the last function here is to stop the process when the Ctrl C is pressed. Thank you. This is all for the coding part. Our system is designed to drop the pigment balls in one by one sequence until all the 8 balls are collected. We start placing the box on the left side with the initial conditions of all the cylinders extended. Firstly, the black button is pressed to start the process. The conveyor belt starts to move to the right. And when the left proximity sensor detects the presence of the box, a ball will be released. And the conveyor belt will continue to move. What happens is that the upper cylinders will retract and extend to load the ball, and the bottom will do the same thing to release the ball. And the conveyor belt will stop when the right proximity sensor detects the box again, and the second ball is released. And then the conveyor belt will change its directions and move towards the left. The box is stopped again and the third ball is released, and the conveyor changes the directions again. The video is fast forward to show how the remaining balls are collected. And this is the last ball, the 8th balls is collected and the systems will stop. In order to prevent mold growth on braid, low humidity must be maintained during the packaging. When humidity higher than 80% is detected, the system will be stopped immediately. Now you can see that the system is keep detecting the humidity. We blow the air towards the sensors to stimulate the humid conditions. And now it's 99.5% and the system is stopped.
Hi guys, okay, I'm gonna tell you the problem we face and safety precaution. The main problem that we face is lack of knowledge and experience of using Raspberry Pi and Python. We managed to overcome this problem by understanding all the lecture given to us, and after we did some self-learning, we basically managed to improve and enhance our knowledge. Okay. Next, we use multimeter. We use multimeter to check the connection and the voltage flow across the circuit to avoid short circuit. We also make sure that Raspberry Pi is always switched off when wiring is carried out to avoid damage to our Raspberry Pi. Okay. In addition, emergency stop is introduced in our system to terminate the system during the emergency, just in case.
In conclusion, we managed to develop a material handling system by integrating various sensor and actuation systems using Raspberry Pi and microcontroller. Lastly, we had learned the Python coding and wrote the code to perform the material handling process. We like to thank to our lecturers and technicians in helping to complete the project. Cooperation between our group members makes our project is a success.